Hello class, welcome to 6.2, use multiplication properties of exponents. Here we have a number of objectives. We're going to touch on them lightly because some of them you've seen before in Math 80. So it'll be more of a refresher here. So now we have simplify expressions with exponents, simplify expressions using the product property of exponents, simplify using the power property of exponents, and simplify using product to a power property, and then multiply monomials. And these names sound a little different or rather lengthy, but it's basically the properties that we've seen before, and it's quite a refresher at this point. So when we talk about exponents, let's say you have a power m, okay? Now we write exponents on the top like a superscript, above the base, and then it's offset to the right top corner. This is the way we write it because it is supposed to be a power, an exponent. So I insist that when you write, that you do it clearly so that the m that is in the power is not too high or too low, so that it's not mixed up with the previous step or is not misunderstood as being multiplied to the a, because this is a power m. So this we call as the base, and the m is called the power or exponent. Now, what this means is your a gets multiplied. Okay, the same a gets multiplied. It's multiplied to itself. How many times? M times. So the power tells you how many times to multiply that base, right? So we call this base as your a, the ones that are getting multiplied as factors, okay? So I'll just say here, factors. And these factors get multiplied m times. So let's look at maybe a numerical example. Let's say we have 2 power 3. Let's just keep it simple, okay? So your base is 2, and 2 is your factor. 2 is what you're going to multiply how many times? 3 times, because you know the power is 3. So it is not 2 times 3. Then I would rather write it as 2 times 3, right? We have a specific operation called multiplication for that. This is a different operation. This is exponents. It's also multiplication, but it's just repeated multiplication, right? So 2 times 2 times 2. It is because of this repetitive style of multiplying the same number, we call it exponents, and it's easier for us to represent it because we can actually see how many times it's being multiplied, right? So I can multiply this out. 2 times 2 times 2 is 8. Okay, so the answer is 8. Now say I have 2 power 15. Okay, just imagine 2 power 15. Now that is going to be really, really large. And for us to write out, expand it out as 2 times 2, 15 times, multiplying the factor of 2 15 times would be cumbersome, right? So 2 power 15 would be a crisp way to denote that information. And on the calculator, it makes it even quicker for us to calculate it, okay? Okay, let's do these problems. Simplify. 4 cubed, 7 power 1, 5 over 6 squared, 0.63 squared. We have 4 different problems. Let's take them one by one. Let's look at A. So it's 4 power 3. Let's expand it by definition. The base is 4 and the power is 3. That means my base, 4, gets multiplied how many times? 3 times. Okay, that's the information there. So we actually can think of, okay, let me multiply this out and then come back to that explanation. Anyways, 4 times 4, 16, 16 times 4, 64, and that's our answer. Let's box it. Okay. I want to kind of describe this as flag, pole is your base, and this power could be seen as the flag, right? So think of this as flagpole and the flag. Can the flagpole stand by itself? Yes, very much. It can stand by itself with no flag. But can a flag stand by itself without the pole? No, it cannot. So you can never have an exponent hanging there without a base, right? And the flagpole clearly is the base. That's the foundation upon which the flag is raised. So you now have an understanding of how the flag has to be attached to the pole, right, to the foundation for it to even exist, right? So when you have powers, right, you want to see what the power is attached to. Okay. So now if I have 2 power 3, then I can see that the power is 3, which is the flag, and it's attached to the pole, which is 2, right? So the power 3 is attached to the 2 because it's right next to the 2. Let's say 2x power 3, okay? All right, so you do have a base and we do have a power. We need to understand what the flag is. The flag clearly is the 3 because that's your exponent, right? The 3 is fluttering in the air. And you need to see what that flag is attached to. Which pole is it attached to? The pole that it's attached to is the x, not the 2x, because the 3 is only to the x, right? So the base is x and 3 is the power. So what about the 2? Well, the 2 does not carry any power. The 2 is simply going to get multiplied to the x cubed. On the other hand, if I gave you as 2x in parentheses power 3, now tell me what is the flag? Well, the flag is 3, which is the power. What's the flagpole? What is it attached to? Well, it's got a grouping happening, right? The 2 and the x are grouped together in parentheses. So that grouping tells you that they have to be considered together. Therefore, the 3 is attached to the 2x, which is in the base. And so that's how you determine what the base is. It's very important to know what the base is so that you know what to multiply 3 times over, right? So the base really tells you here that you have to multiply the 2x 3 times. So it's going to be 2x times 2x times 2x for this problem. But for the previous one, when we said 2x cubed, that's going to be 2 times just x times x times x. So I hope you got the understanding of the base and the power. And let's come back to simplifying. Looking at problem B here, 7 power 1. So look at the power. The power is your flag. Flag is 1. And the flagpole it's attached to is the 7. No question about, any other numbers around it because it's just the 7. So you know that your base is, excuse me, you know that the base is directly a 7. So the 7 has to be multiplied how many times? Just 1 time because the power is 1. So the answer itself is 7. Okay. Then let's look at C, 5 over 6, the whole power 2. Now we have to ask ourselves the same question. What's the flag? The flag is 2. What is the pole that it's attached to? Well, the 5 over 6 is grouped together in parentheses. So you know the entire fraction, 5 over 6, is your base. This means your 5 over 6, the entire thing gets multiplied 2 times because the power is 2. Now it's a question of multiplying 2 fractions. We know that we multiply 2 fractions by multiplying them across. So 5 times 5, 25, over 6 times 6, 36. We always try to reduce it, but in this case it's not reducible, so we box our answer with that expression. D, 0.63 the whole squared. Here again, the power is 2, which is your flag. It's attached to the base, which is 0.63. It's grouped there. It's just to give clarity when you have decimal numbers, because really there's only one information, one factor in the base. So you really didn't have to put the parentheses. As you can see, it was a decimal number, and so we like to put the parentheses for clarity. And then this gets multiplied 2 times over. Remember that we always like to put a 0.63 instead of 0.63, just to show that we intend it to be a decimal point. It's not a stroke of your pen. Right? Use a calculator. Do 0.63 times 0.63. You get 0.3969. You must get 4 decimal places because you're multiplying two numbers with 2 decimal places, so a total of 4 decimal places. So all that looks right. We got an answer. Let's box it. So this is just trying to understand the base and the exponents. Now let's try to really understand how this works using the flagpole example. Okay. So we have a -5 the whole power 4. So let's determine what the exponent is. That's very obvious, right? It stands out very clearly. That's the exponent. We need to see what it's attached to. It's attached to the -5 itself because the -5 is grouped, meaning the negative and the 5 both are grouped. So that's your base. This means your base, -5, gets multiplied how many times? 4 times, because the power is 4. Okay. So when you have these kind of expressions, it's a good idea to tackle the sign first and then go for the number. So negative times negative is positive. Negative times negative is also positive. You can see it like that. Because you have even number of negative signs, you know it's going to give you a positive answer. Or you could go through it from left to right. So negative times negative is positive. That positive times the negative is negative. That negative times negative is positive. Okay. So you can go from left to right by taking 2 signs at a time, simplifying them, or you could group them by pairs so that you know they give you positive, right? So anyway, we got a positive sign from all of these minuses. And then now it's time to multiply just the 5s. So 5 times 5. Again, you could do it in pairs. 5 times 5, 25. And this is 5 times 5, 25. 25 times 25, 625. You could do it like that. Or you could use a calculator and do it one by one. Remember, the question is about using easier means to get your calculations. So always rely on your commutative property, associative property to help you guide into how to group them or simplify them to get your multiplication done quickly. All right, b is -5 power 4. Okay, so let's look at our exponent. The exponent is still 4, very clear. See what it's attached to. It is attached to the 5, right? Not the minus, just the 5, because there is no parentheses to group the minus with the 5. So you know that your base is just a 5. What does this mean? This means that you have to keep the minus, out of the picture and just focus on the base, which is your 5. So the base is 5 with the power 4, meaning the 5 gets multiplied 4 times because of the base. This is a very good example to give you that clear distinction between the grouping, the importance of parentheses to say if it's grouped together or not, versus without parentheses, where you're strictly going by the number the power is attached to. So the minus gets tagged along because it has nothing to combine to. So keep the minus as it is, multiply the 5s. 5 times 5 times 5 times 5, 625. So your answer is -625. Okay. We move to product property for exponents. Okay. This is a property that you have seen in Math 80. If not, it's okay. It's a quick refresher at this point. So remember this, if you have to multiply 2 terms with the same base but different exponents, it is, you're not going to multiply the powers, instead you'll be adding the powers, okay? So that is an important property. It is slightly counterintuitive, but if you think about this, as I'm going to show you the next example, you can see why we have to add instead of multiply. Okay? So we multiply like terms with like bases by adding their exponents. Let's take a look at this example. Let's take a. a power 7 times a. Okay. All right. Now I don't see a power for the second a, but if you don't see the power, you know that the power is 1. Right? So if we use the property directly, the property simply says add the powers. Okay. So I'll just say here by property. Yeah. A power 7 times a power 1 is the same as a power 7 plus 1. Remember, you're combining this, so you don't have another a. You combine the two separate a's into a single a when you add the powers. It simply becomes a power 8. Now, we don't know what a is, so you cannot really expand this any further. So go ahead and box the answer. This is by property, so it happens instantly, right? But if you think of this as a concept, okay, so I'll just say the properties are always quick means of getting the answer, but they always come from the concept, isn't it? The concept doesn't change. So a power 7, let me expand that, okay? 1, 2, 3, 4, 5, 6, 7. I multiplied a 7 times the other a, right? Now count how many a's we have. 1, 2, 3, 4, 5, 6, 7, 8. If I were to simplify this again, this would be a power 8, which is what we got as the answer. So the concept is still the same. Let me put it out like this. This is your a power 7. So the concept is still the same. And when you expand it and multiply them out, and you count how many times the factor a is repeatedly multiplied, you understand that it comes out to be 8. This is what is captured by the property. We love properties because they are shortcuts to get to the answer. But remember that when you cannot remember the property, or when you need a little more clarity, you can always fall back on the concept, because the concept is where the property comes from. All right, let's look at this. X power 27 times x power 13. This is a place where it is absolutely essential that you know the property, because as you can see, it can be cumbersome to write out x being multiplied 27 times and then the other x being multiplied 13 times. This is the reason why we insist on the property, because your property really helps you to answer this question very simply. So I'll just say by property. Again, there are plenty of properties because they behave differently when you multiply, when you divide, and so on. So you really want to know what that property is. And when I'm saying by property here, it's simply because we've only seen the first property. Okay. And you can always pause and go back to see what property we're talking about. Okay. All right, so 27 plus 13. So this is going to be, it's simply a question of adding the powers. So 27 plus 13 gives you 10 x power 40. Okay, so we got that. Now, again, these ones, we would generally expand these further if they were regular numbers, or if they were, like x, if they were very large numbers. Say instead of x, you had, let's say, 21. 21 power 40 is going to give you a very large number. We don't expect you to expand it. So it is totally fine if you had to leave it like this, okay? But if it was simple ones, yes, we expect you to expand it and give the answer after evaluating. So we look at the next property. It's called the power property of exponents. If a is a real number and m and n are whole numbers, then a power m power n is 8 power m times n. Okay, what does this mean? Power property, as you can see, a power m has another power n. So the powers are stacked up, right? You have a single base and you have two powers that are stacked up. And the property says, hey, simply multiply the stacked powers. Okay, this is where you will end up multiplying them. Okay, in the previous property, we added the powers when they came from multiplying two separate like bases, right, with different powers. But here you have a single base with stacked powers. We're saying multiply if the powers are stacked. Power to a power, multiply them. Here's an example. Let's look at A. Y power 5, the whole power 9. Okay. All right. The power is 9 and the base is y power 5, right? That's how we understand this. But you see that the base already has a power, right? So then you will begin to see this as power to a power. So you have y power 5, power 9, okay? 3 layers. So the property, again, if you were to expand this, okay, that's going to be cumbersome, but I can kind of verbally explain it. If you were to expand this y power 5, this is going to be y power 5 times y power 5 times y power 5, like that, 9 times, right? Yeah. And then each y power 5 will have to be further simplified as y times y times y, 5 times like that. Like that, you're going to do it for each one of them, and we're going to figure out what the total y's they will be that are being multiplied. As you can see, when I verbally explained it, you could see that you had several layers that to drill it down in order to begin to count the number of y's. But by using the power property, say that, by power property, you simply try to understand that stacked powers get multiplied. So 5 times 9. 5 times 9 is 45. So if you had expanded it, it's going to be expanded out. You're going to write the y 45 times, right? Because you have y power 5, so y being multiplied 5 times. And like that, you're going to do it 9 times. So 5 times 9 times is 45 times of y being multiplied. Okay? You can see how interesting it is to apply the properties right away. 7. So once again, I see powers stacked up. So by power property, 4 power 4 power 7 is 4 power 4 times 7. Okay, 4 times 7 is 28. The answer comes out as 4 power 28. Here again, well, with y power 45, we could not expand it because we didn't know what y was. Even otherwise, the 45 was too large, right? But if you look at the second one, the second problem has numbers. They're all numbers. So 4 power 28, it can be evaluated. But if you used your calculator, it's going to give you a very, very large number. The whole point is to write it crisply, so without compromising the actual answer. So we simply box this because it is a very large number. So you might wonder, well, how do I determine if it's a very large number? How do I know when to do or when not to do? A typical rule of thumb could be a 5-digit number. Anything more than 5 digits, technically, could be left as power, okay? For our classroom purpose, I mean. But if your assignments in your exercises in Newton, if that requires you to write out, even if it's a large number, then you have to go by it. But as a general rule, this is what we go by, okay? We consider it as a large number if it is more than 5 digits. And so we will leave it as an exponent. The next property is called the product to a power property for exponents. Okay, so examine the property. The property is AB, the whole thing, power m, expands out as a power m times b power m. All right, so now you have a single power m, right? And if you look at the base has 2 factors, 2 numbers, 2 terms that are being multiplied, a and b. So when you have 2 factors, 2 or more factors in the base, that's your base because the parentheses has grouped them together. So you know your flag M is attached to the flagpole that is AB. So if you have AB, you have 2 factors there. And what this property says is each factor gets the power M. A gets the power M and B gets the power M and they get multiplied. Okay? So power to a product property. Here's a problem. Okay. negative 9d the whole squared. Okay. Let's examine this. The power is 2. I tried using different colors. If it's too light, maybe I'll not use it again. Okay. All right, you have the power that's being attached to the base, the flagpole, which is grouped as negative 9d. So the entire thing is your base. Right? Okay. Now your base has 2 factors in it, right? You have the negative 9 and the d. 2 factors, negative 9 and the d. So according to the power to product rule, right, by power to product rule, the negative 9 gets the power 2 times the d gets the power 2. I like to put it in parentheses just, to keep them, what do I say, collected. Because with the negative and all that, I like to put the parentheses. So if you, especially with the negative, if you didn't put the parentheses, it's going to make it completely wrong, right? Because it becomes negative and only the 9 gets the power 2, which is incorrect. Negative 9 was grouped together in the base, so that negative 9 gets the power 2. That is grouped. The d also gets the power 2. This is the reason why I like to put the parentheses. Negative 9 power 2 is negative 9 times negative 9, which is positive 81. D squared cannot be simplified, so we simply write it as d squared and box your answer. You can see how instantly your answer comes out to be. Okay, next it comes to B. Okay, try the darker color this time. 3mn the whole power 3. Okay. A lot of 3's there. Doesn't matter. We're only focusing on the rule. So once again, let's examine what the power is. The power is 3. And the base is all grouped together by the parentheses. So your base is the 3mn. So see how many factors you have. The base has 3 factors. 3, the m, and the n. These are the 3 factors, right? Once you identify the 3 factors, it helps you to carry the power to each one of them. So 3 gets the power 3. M gets the power 3. I can put a dot in between to show they're being multiplied, or I can leave it like this because the parentheses indicates that they're being multiplied, right? Okay, 3 cubed. 3 times 3 times 3 is 27. M cubed, well, it has to be m cubed, cannot expand. N cubed, again, cannot expand. So that is your answer upon using the power to a product property. Again, if instead of m and n, if you had other numbers that were simpler, you could actually go further and multiply them out, right? So here we just stop with that, that expression. So let's take a look at all the 3 properties quickly. The product property was when you multiplied the 2 like bases separately, then you end up adding the powers. Power property says if your powers are stacked, multiply the powers. Product to a power says if you have multiple factors in your base, each of those factors will carry that same common power individually. Okay? So for these exercises, we may be required to use one or more of these properties. Okay? These are combination problems with a combination of properties to apply. So let's take A, y power 3 power 6 times y power 5 power 4. Well, let's take them, let's try to understand what this problem is giving us. It's giving us 2 things that are being multiplied, right? They are grouped differently. So let's focus on this first one, y cubed power 6. So you look at the base, you look at the power, and then you look at the base. The base has a power, and this itself has another power. So the powers are stacked. So you can clearly see that this can be written as y power 3 times 6 because we're using the power property. Okay, that was one part of the problem. The other part was there is no sign in between, but it tells you that because of the parentheses, it's being multiplied. Right? So you have that. And then you have y power 5, which is raised to the power 4. Once again, similar situation, you have stacked powers. So multiply the powers 5 times 4. Let's take them slowly. So y power 3 times 6 is 18. And y power 5 times 4 is 20. Okay. I did not put any sign in between, but you know what that means, right? If there is no symbol in between them, it just means they're being multiplied. But we know they're being multiplied right in the beginning because you have the parentheses. Okay. So if you want, you could put parentheses to keep that going. Yeah, like this. So you know that it's multiplication all along and you're not tempted to do anything differently. So now you have y power 18 times y power 20. Just before that, let me quickly say here that we use the power property. Y power 18 times y power 20, I have two like bases. The bases are alike with different powers. So we have to resort to the product property, which says you have to add the powers. Right? So this becomes y power 18 plus 20. This is because of product rule or product property. And y power 18 plus 20 is y power 38. We box the answer as we cannot expand this any further, right? Got that. Let's look at problem B. It's negative 6, x power 4, y power 5, the whole power 2. Wow. So you have one overarching power, which is a 2, and all of these are your base. Okay. So let me write that out here. This is the power. This whole thing is your base because it's grouped, right? Now the base has different things happening. So let's see how many factors we have. Well, we have negative 6 is one factor. X power 4 is another factor. And y power 5 is another factor. By identifying the individual factors, we can now assign each of these factors the same common power that they all got, which is 2. So negative 6 gets the power 2. X power 4 gets the power 2. Y power 5 gets the power 2. This was power of product property. All right, let's take them one by one. Negative 6 power 2 is negative 6 times negative 6, which is positive 36. X power 4 power 2. So look at that. Those powers are stacked up, right? So you have 4 times 2. You need to multiply the powers. And here again, 5 times 2 must be multiplied because they're stacked powers. This comes from the power property, where it asks us to multiply stacked powers. Okay, so 36 x. 4 times 2 is 8. 5 times 2 is 10. So it's 36 x power 8, y power 10, which is our final answer. Let's do this set. Multiplying monomials. This was our last objective. So let's see how this works. Multiplying monomials. Monomial means single term, right? A term could be a combination of numbers and letters raised to powers. So you have a single term being multiplied to another single term, and we're trying to see how to handle this. Well, let me write this problem here. 3x squared times negative 4x cubed. Okay. If you see this, they're all being multiplied, right? It's like this, 3 times x squared, because they're attached just means they're being multiplied, times the negative 4 times the x cubed. Are you with me on this? So we are multiplying them individually like this, right? And by commutative property, you can move them around. Commutative property of multiplication allows you to move their positions without affecting the answer. So what I did was I grouped the numbers together, I brought the numbers together, and I brought the x's together because it's easier to combine them that way. 3 times -4 can be multiplied together because they're numbers. Gives us -12. What about these two? X power 2 times x power 3. Two x's, same base with different powers that are being multiplied, which means we use the product property, which asks us to add the powers. So 2 plus 3. One more step, we get -12 x power 5. That will be our answer. So this is a case where we multiplied monomials, but we had to use the other properties. In this case, we used actually, we used one property, which is product property. But sometimes you may be required to engage in multiple properties. But as you can see, we multiply the numbers together, we combine the x's, meaning the like bases together. Okay, combine numbers, combine like bases together. That's the only way to handle this. Let's look at this last problem. 5/6. I'm going to separate them out like this. Eventually, you don't have to do this, right? Because you could actually see them and group them directly. But this is just our first experience with these types. So I'm going to take it slowly. I multiply the numbers together. They're all being multiplied, so please multiply them together. And I'm going to multiply the like base together. I'm going to put a 1 here so you can see that it has a power 1. So x's are alike, so I put them together. Y's are alike. This y doesn't have a power, so I'm going to put a power 1. The y's are alike, so they get grouped together. And we're going to group them by their likeness. Okay. Now we have a fraction, 5/6 times a 12, times the whole number. So, you could simplify this. Okay, you can cross cancel them. That gives us 5 times 2, which is 10, times x power 3 plus 1 times y power 1 plus 2, which comes down as 10 power x power 4 y cubed. And that is our answer. So some problems can expect you to do a little more work. Again, we are well beyond the situation where we're worried about fractions. We know how to handle fractions. This is a very, very simple fraction. It's nothing at all, right? So you just have to remember that you have to handle your fractions and they're being multiplied, so it's possible to cross cancel and simplify it. You got your answer. I hope that's helpful. I will see you in the next video. Thank you.